All right, the 68, 95, 99.7 rule. It is so important. In fact, it is so important. I am about to write right here that you just need to memorize those values. All right, so what this rule says is that in any normal distribution, approximately 68% of your observations fall within one standard deviation of the mean. And my dog is going to town. I don't know if you guys can hear her or not, but her snores are mighty. And yes, Louise, I am about to show you a photo of her because I had a request earlier for a photo of my dog. All right, so remember when we were talking about the class heights earlier in the week, and I talked about that anyone who was more than one standard deviation away from that center, there was some significance to that, because you can see the majority, 68% of our values, fall within one standard deviation. That's 2/3, over 2/3. All right, so they all fall within this center. So within two standard deviations, okay, so within two standard deviations, so this next set, okay, it's starting to go away on me. Okay, so if I fill in this next area, this is 95% of our standard deviation. And remember, we had some tall people in our class, and I believe they were over 2 standard deviations away from the mean. So that means that they're in this area over here. So, oops, I think I just freaked my computer out. Okay, there we go. Oh, no, we ended it. Okay, so this area over here is where our tall people are lying. So they are in a very small area. So to be that tall in our class was slightly unusual. Doesn't mean it's bad, doesn't mean it's good, just means we wouldn't expect it to happen in our samples. That's a little surprising. Okay, so that's where we're going next with this. Okay, so and then of course 3 standard deviations away. Okay, so these groups, that is where almost everything in a normal distribution, so that's key, in a normal distribution, 99.7% of our data should fall within 3 standard deviations above or below. So remember, that's 6 standard deviations total within our mean. So really important that this is for normal distributions only. And we're going to get more specific about what normal means and all those things in just a moment. But, okay, really important. So let me see if you have any questions. All right, here she is. Here is the snoring offender. Yep, she's just been snoring logs, and this is her laid out on my bed, snoring away. Yep, that's her. Her name's Praline, by the way. I think some of you might ask. Yes, her name is Praline. All right, let's look at an example here, because you very often are going to need to be able to sketch a normal curve to demonstrate that you understand your distribution. So that's what we're going to do in this problem, and we're going to label it correctly. Every time you do a normal curve from now on, you really should label it as accurately as possible. Okay, that might be the straightest line I've ever drawn on this thing. Okay, so we're going to start in the middle. Our middle is always where our mean is going to be. So there's our mu, and it says in our problem that we've got a distribution of heights, American men. It's approximately normal. Doesn't mean it's exactly, but it's close enough. We can use a normal curve. 69 inches is the mean. So right here in the middle, I'm going to make a 69. Now, since it's normal, I'm going to draw my curve. Now, here's how I'm going to try, and this computer may not be perfect. But here's how I recommend on your own paper, is actually start at the top and go down. Oh, that's actually pretty good. And then go back to the top and repeat for the other side. I have found over the years, if I try to go from left to right, I never end up with my center where I want my center. It looks all funky. So actually on this computer, that was pretty good. All right, so then we're going to approximate where 1 standard deviation is away from the mean. So it's going to be about there. So you can see if this does look like it's about 68% of my values would be in this middle section, okay? All right, so go back to the pen. So that means that this is -1 standard deviation away, and this one is +1 standard deviation away. So then we're actually going to calculate that. So 69 minus, what was our standard deviation? 2.5. Okay, so 2.5 then for 69 down from that would be 66.5. And for 1 standard deviation above that would be 71.5. So I'm just adding or subtracting my standard deviation of 2.5. All right, so let's go out to up where we feel the 95% area is. I think I'm feeling pretty good about that. So this is going to be +2 standard deviations and -2 standard deviations. So if I subtract, this one's going to go down to 64. This one's going to come up to 74. All right, and then my last one, of course, I should only have a tiny little bit of curve left right here. So right about here. All right, this is 76.5, because if I add, so this was 3 standard deviations above the mean. Then down here, I've got -3 standard deviations below the mean, and that next area would be at 61.5. So down below, our axis is telling us where those standard deviations hit, and above, it's telling us how many standard deviations. So I'm going to relate this back to our z-scores, because that's where we're going. Let's take a look at 3 standard deviations. What that's saying is that in this problem, okay, a z-score of 3 standard deviations would happen when an American male was at or above 76.5 inches in height. Oh, we're starting to get there. Okay, this one right here, in order to get a z-score of -1 standard deviation, then a gentleman would need to be 66.5 inches in height. Okay, so that's how you can convert. So if I did my 66.5 minus my 69 divided by 2.5, it would give me my z-score, which is -1 standard deviation. It's starting to come together, hopefully, why our normal curve is so powerful. So let's take a look at where we're going to take all of this next.